Hello, Year 12, and welcome to this last minute revision for flow in, flow out problems with our differential equations. Right. Let's have a look and see what we're talking about here. This is a question that came from a past HSC paper, VCE paper actually, not HSC, but from our past HSC materials. And in it, I have this problem here where I have a 16-litre tank with half a kilo of salt. Sorry, 16-litre. I have a tank with 16 litres of water in it, which includes half a kilo of salt. Okay, into this tank, 5 litres of fresh water flows every minute. Fresh water is coming in. And then 3 litres of salty water is flowing out. Now we know how fresh the fresh water coming in is. It's fresh. How salty is the salty water going out? Well, it changes, doesn't it, depending on how much salt has gone out. Because there's no more salt coming in, the tank is becoming fresher all the time. Okay, so the amount of salt leaving is changing all the time. Anyway, we're asked to find this differential equation to describe the quantity of salt in kilos in the tank after t minutes. So what are we going to do? Well, we need to look at what's going in and what's coming out. And what's going in is pretty straightforward. How much salt is coming in? No salt. No salt comes in. 0. How much salt is going out? Well, 3 litres of salty water is going out. Now, when I say salty water, how salty? Well, it's 3 litres multiplied by however salty the water is, the concentration of the water in kilograms per litre. And that's changing over time. Well, I'm going to need to investigate that a little bit further. The concentration is the amount of salt divided by the volume, and the volume is not fixed either, is it? That tank might start with 16 litres of water, but when 5 litres go in and 3 litres go out, that's increasing the quantity of water in the tank every minute. Right, so if you like, we can come up with this little function of volume. The volume as a function of time is 16 plus 5 litres per minute minus 3 litres per minute. So we could say it's 16 plus 2t is the volume of the tank. The concentration is however much salt is in there divided by 16 plus 2t. So that's my concentration. Coming back now to our salt out equation we generated up there earlier on, it's 3 multiplied by the concentration, so 3q over 16 plus 2t. Now combining these things, the salt in minus the salt out is 0 minus 3q over 16 plus 2t. That's the change in salt per minute, or we might describe this, the rate of change is to q under t equals negative 3q over 16 plus 2t as required. I think that's the tricky part of the question, really. But it's not all of the question, that's only the first part. So let's look at the second part, part B here. Solve the differential equation found in part A, and we were pretty lucky there that even if you didn't get that equation, you've still been given it, so you can still differentiate. You can still solve it here. So we got that. Express in this form, again, I quite like this question in the sense that it's directing you on how to present your answer. And we've had a bit of confusion about how much manipulation to be done right at the end of that question. But here we can see exactly how much to do. Like this. So let's get that equation to q under t equals negative 3q on 16 plus 2t. To solve this, right, I'm going to drag that q from the right over to the left. So I've got 1 over q multiplied by q under t equals negative 3 over 16 plus 2t. Okay, all the q's are on the left. That's good. Integrate both sides, I suppose, with respect to t, but you know the t's cancel out, and I end up with the integral of 1 over q to q equals the integral of, well, this thing here, 3 over 6, or negative 3 over 16 plus 2t. T's, there's only first power of t there, right? T, something over t, makes us think that you should recognise that as a log, okay? So the function that in the denominator is 16 plus 2t. The derivative of that is just 2. So what I'd really like, I'd like to be integrating 2 over 16 plus 2t. But I'm not. So let's put the 2 up the top, and we will balance that out by putting a half up the top as well. Okay, we should be happy enough saying 3 times 2 times a half is still just 3. Right, we got that, and then I'm going to take some of those coefficients out the front, the negative 3 over 2. And I said I'd quite like to be integrating 2 over 16 plus 2t, because that's a straightforward log, and now I am, with a negative 3 over 2 there. So, integrating these things, we end up with the log of the absolute value of q equals negative 3 over 2 times the log of 16 plus 2t, absolute value, plus some constant. Now, e to the power of both sides is a bit of a problem there because it's not a straight up log. got a multiple of a log. So I'm going to use my log laws and take that -3/2 and make it the exponent, the power, if you like, of the 16 plus 2t. So we've got this. Now I can do e to the power of both sides. And of course, e to the power of log q is just the absolute value of q. Well, what happened there? I made that I put the plus c, I changed that to a multiplied by e to the c, so I broke that up, so that I can now say the absolute value of q is e to the power of c, multiplied by 16 plus 2t to the power of -3/2. Now, if I say a equals plus or minus e to the c, we've done that many times, and instead of having a negative power, how about I get rid of that negative in the exponent and turn this into a fraction? So I get q, not absolute value anymore because we've got plus or minus e to the c equals a. Q equals a over 16 plus 2t to the power of 3/2. That's looking awfully like the answer that we're asked, but I've got a capital A there and I can evaluate that because I have been given the initial conditions. We know that initially there was half a kilo of salt in the tank. So Q0 at t equals 0, Q equals 0.5. Substitute that in the equation that we just generated there. We get 0.5 equals a over 16 plus 2 lots of 0, 0 time, 0 minutes, to the power of 3/2. Now, of course, 2 times 0 is 0, 16 plus 0 is 16. 16, you know, is 2 to the power of 4, and 0.5 is 2 to the power of -1. Multiply both sides by 2 to the power of 4 to the power of 3/2. Sorry, rabbit roll a bit here. You could just plug that into your calculator, you're going to get an answer. But let's use our index laws. Tidy that up a bit, and we get 2 to the power of 5, which is 32. That's nice, a equals 32. Didn't have to use the calculator. Now, putting that back into the equation, Q equals 32 over 16 plus 2t to the power of 3/2. That's in the form that we were asked to provide, in which case a equals 32, b equals 3, and c equals 2, as expected, as required. That's it. That's done. That's a fairly tricky question. I know I spoke very quickly, but I'm hoping this is recording properly because it didn't last time. I lost the sound again. This is second go for the evening, and the kids are pestering me for dinner. So hopefully that's all there. I can't find the stop button. It's going to get scrappy here at the end, isn't it? Yep. Okay, that's it. Hopefully all makes sense. If not, send us a message as soon as you can, and I will help out. Okay. Thanks very much, guys. That's us. Done.